Quick disregard before this video starts. Watch it all the way through one time before actually following along. On the second time you can follow along because if you watched it the first time you'll have realized that I messed up on assembling some of the parts together, which will later interfere with putting on the motor mounts.
Well, one important step for designing any part in an assembly is making sure that your parts don't move on you when you don't want them to. You can do this by selecting. Another thing is, whenever you're adding parts to an assembly, always make sure that they're different colors. The reason I say this is because it makes it a lot easier later on to identify different components on an assembly. You can choose whatever colors you want for this. Right now, I am currently just spacing out all the components on the assembly, but once I got one side spaced out, I'm now going to attach the bearings onto the channel. For this, I'm just doing an insert constraint. And I'm doing the exact same for the other side. Now that both of the bearings are added, I am actually adding spacers. As I said earlier in the video, I actually messed up in one part when designing this. If you want to make it easier on yourself, move both of these holes placements for the bearings one further in, because they later interfere with the placement of the motor mounts because the screws would hit each other. Now I'm adding collars onto the end of this. This isn't how you would actually build it in real life, but this is the easiest way to build it in Autodesk Inventor. When using this constraint, just find any two circular parts of the object and then connect them together. This would allow the part to rotate like it normally would. If you want to be more advanced, you can even take your axle and constrain it in a way to your collar so that they'll move together, compared to both being freely independent. Now both axles are actually added in, and we're going to be working on the other side. First, we're going to drag both bearings to their placement, and then we're going to use the insert constraint and constrain it in. Sometimes your part might be facing the wrong way, so you can just click the button which I just did, which will allow you to change the direction of the part. And now I'm adding both of the spacers onto the bearing. This one I was having problems with because I selected the wrong part of the spacer, but I just kind of went with it because it doesn't have to be exactly perfect, but it does have to show the representation of what it will be. And now I just added one collar on, and I am about to add the second collar on. And I just had to change the direction again because it was facing the inwards instead of outwards. Now I just tried to select the outside of that, and then I'm gonna select the inside of this adapter, which actually connects the axle to the mechanism wheels. And I'm doing this on both sides now. And as you can see, they both were able to move freely. Okay, now I pretty much just added both, or I saved that part and then created another assembly and added two of the exact same one into here. And you just drag them to where you want them. And also I added 2 other C channels into here, which all these parts will be in the part files for the Mechanism or Gobilda Mechanism strafer chassis. And I just kind of laid them out to where I basically want them to be. Now I'm going to be changing the orientation of them so that it makes it easier on me later on when I start constraining them. Now I'm just using a flush constraint, which makes sure that they're both even with each other. And now I'm trying to select the inside part so that they're joined together. Now I'm trying to add the third constraint, but for this one, there's not an easier or super easy way to do this without having other parts in the assembly. So for this, I am just kind of doing a guess and check to get it close to the right position. And then once it looks close enough, I'm gonna set it in place. As you can see, I'm trying to eyeball this and to get it close to the right place. It's slightly far off, so I'm gonna keep changing it until it looks perfect. Final number for this is actually 72 millimeters. And now we have one corner done. Now we're going to do the exact same thing for the other side. And we just added one constraint, and now we're adding the second constraint. And now we're gonna type in that 72 millimeters, and it should bring it to their proper place. Also remember, when creating the part, make sure to unground it from the previous assembly, and then just reground it in this one, because if you don't, it'll start producing errors. And now we're doing the other side also. It's the exact same process that you did for the previous side. And there we go. We just have to add the one last constraint to that one, and then it should be fully connected. This part kind of confused me, because you used to not be able to add any more constraints when it's already fully constrained, because it would just say you're over constraining the part. But for some reason, I was able to add 2 more constraints to this. And now we are actually going to be working on the wheel itself. For this, since the wheel is pretty much pre-constrained, I am just going to be adding the colors so it makes it more accurate for what the actual Gobilda Mechanism wheels look like. Which is black on the outside, and then black in the center, and then yellow rollers. And one easy way to do this is by actually holding the control or shift, I forget which one it is off the top of my head, and then you can just select all the parts, and then after you click on the color menu, you can let go of that, and then click on the color you want. Okay, now we're actually going to be taking this mechanism apart, because when they made this previously, it didn't have constraints when we downloaded it. So I'm just dragging everything apart, which I'm doing this super quick because it's a time lapse. And now we're also going to be adding color to it. For this, I just used the basic polish color. Okay, now we're going to be constraining the first plate, which is actually the motor or front motor mount. And that is just going to be constrained to the motor using a flush constraint. or joint constraint. And now I'm going to be using a insert constraint to join both or two holes together, just so it's fully connected. Okay, and that's one connected. And now I'm able to pivot it on that, and it will still be flush on the part. And now we just added the second one. So now you see it can't move. And before I would do any of this, I actually would want you guys to constrain this motor so that it wouldn't be moving when you're trying to move or constrain the two parts together, because it just makes it easier on yourself for your view of the part. And now we're just adding screws, and for this, just use a insert constraint. And this was just me trying to change the color of the motor, which later on, after I saved it, it actually gave me an error, which wouldn't allow me to change or add any modifications to it, which is normal. So it would just save itself in here with the color, but in your final model, it wouldn't have it. So in the final model, you'll have to add color again. And now we're just adding more screws in. Something else that I didn't mention is, as you can see by the part I'm adding color to right now, this part actually I don't want it to move because of the spacing between the two gears, so I actually have that grounded, which then after I'm done modifying this, I'm going to unground it so that it is able to be moved later on. And now I'm just adding the screws onto the outside. For this, I'm just kind of doing a insert constraint, but I'm also trying to guess the distance between the screw and the bracket for where the C channel would be. If you wanted to do this in a better way, just don't have add the screws here, add them actually later on. So that way you get the exact distance that you want. And I'm doing the exact same thing for all the other screws also. A lot of things in assembling a kit like this from Gobilda is it's super difficult. It's just, it can be very time consuming, because for this I'm adding all the screws just so it looks good. But if you don't actually want to, you don't have to. It's just kind of an aesthetic thing. Now I'm just adding the last screws into the gear and the gear holder. And it's the exact same process for the other three. One key thing about Inventor is, or any CAD software, is it's all about the view. You can do some pretty complex things if you actually are able to get a good view angle of it. and that was the error I was talking about, and you're going to see there's going to be no color on those motors. Okay, now I'm just going to be adding the screws and washers onto the wheels. This is also another one of those tedious processes where it's just doing the exact same action over and over again until you're done. And here's what I'm talking about by it's all about the view. Because sometimes if you don't have a good view, you might not know actually what you're clicking on. And for this, I just kind of dragged them all apart, and I am just going to continue adding them on. At this point, I was just trying to find an easier way to add them all, or a faster way to add them on, which I actually was able to do by just dragging all the spacers apart and then just adding them all on. And now I'm going to add all of the screws actually on. And I'm actually going to be only doing this for one of the wheels because I'm going to do the rest of them off camera. Now I'm going to be adding the wheel actually onto the wheel mount. One thing that isn't as necessary, but it is in the final design, is make sure that your wheels are actually in an X formation so that you're able to strafe. And also, you just saw an error popped up, and it's because my wheel was actually still grounded from when I was adding all the screws on because I didn't want it moving. Now it's going to be ungrounded, and now I'm able to add it on to the wheel holder freely. And I'm just checking to make sure it won't hit, and then accept the constraint. Now all four wheels are actually on, and I'm going to be adding the mounting hardware for some of the other components that can be added to this. I don't know what these parts exactly do because we've never actually built this chassis, but we've messed with it in CAD sometimes. But these two plastic pieces, I don't feel like they are super necessary because they aren't used for driving. Okay, now we're going to actually be adding the mounting hardware, which would connect the channel to the other channel. And this is what I was talking about. Your motor mount will actually end up hitting this. So a way to prevent this is by moving that channel further in, or just adding or moving the wheel into a different position, because that would move where your motor actually would sit in the drivetrain. And the easiest way to add these on is actually just by doing an insert constraint and finding the holes that line up best. And I'm actually just rotating this around so I have a better view of the hole that I'm going to be selecting. And another tip is whenever you're working with this and you make a mistake, you can always just hit escape. But if the mistake has already been made, you can always just click your back arrow, which is up in the top left-hand corner. And as you can see, they do not move. Now I'm actually going to be adding all the screws into this part, which is another tedious process because normally you wouldn't add screws into a basic design but it's easier to do if you know how many screws there actually is going to be, so then you can order the proper amount. Now I'm actually just adding the last few screws to this side of it. I actually selected the wrong hole in here, which I am just going to hit escape, and then I'm going to reselect the right hole. Okay, now I'm just going to be adding on the motor mount. I'm actually currently just dragging them to the position where I think they would work best. And then once I add them all in, I'm going to just be constraining them. As you can see, the motor mounts actually are hitting the screws from holding the panels together. And this is what I was talking about by you should move one or the other in further so that it wouldn't actually be hitting. Now I'm just adding all the constraints to hold it in place. And something super useful that you can also do is for this kind of constraints, or any constraints, you can actually still use negative numbers if you don't want to change the direction of the constraint or change the type. Okay, and there we go, that one's added. Now all of them are going to be added off camera, just so you guys don't have to sit through that. Okay, now something cool that you are able to do is actually make the wheel spin using motion constraints, which pretty much just binds the motion of different components together so that they'll rotate either in the same direction or opposite direction. You'd use the same direction for here because we want the wheels rotating in the same way, but you would use an opposite constraint if you want to bind both sets of wheels together to move in the same direction, or if you are trying to use gears which spin in opposite directions. Here I actually used the wrong constraint at first to make them move, so when I actually rotate it, you'll see both wheels will rotate in opposite directions. And I did not hit back there. I'm actually scrolling down to the constraint, right-clicking on it, and then hitting edit, which then I'm able to just change the direction that they move. So now they move in the correct direction. And there we go, there's the basic robot, and here's an overview. For this video, you actually have homework, and this is try and repeat what I did in this video on your own without watching the video, but if you still need help, you can continue watching this, and this will allow you also to create other assemblies using this, but I also want you to create custom components.